Hey there, and thank you for joining this session on the rapid delivery of emerging technologies using modern prototyping techniques. My name is Richard, and I assist companies in ASEAN as a prototyping architect for AWS. I personally come from extensive experience in software development and processes, having been building apps and systems since 2006. And I've had the pleasure of leading engineering teams successfully modernize systems for both startups and enterprises in Australia, New Zealand, Japan, and Canada. In my capacity with AWS for the past 3 years, I have had the privilege of not only providing recommendations and engineering guidance for hundreds of companies in ASEAN, but also actually building out the prototypes that eventually help these companies accelerate, modernize, and solve some of their most critical business problems. Today, I'd like to talk a bit about how we can help your companies walk that journey as well. How prototyping can be a medium for you to quickly and efficiently modernize apps and systems. I'll also talk about some of the trends we're seeing with these new and emerging technologies. And I think a very significant majority of folks do want to keep up with changes in tech, whether it be to introduce new features to a product or to address a market need in a more innovative way, or maybe even just to stay relevant in some cases. Being able to use some of these exciting new technologies allows us to harness some pretty good business benefits. The challenge that a lot of people face is just the sheer overwhelming pace of technology itself. It's a perpetual moving target. I'm sure you know that technology moves at a very fast clip. What we're seeing, though, is that not very many have a concrete idea of just how fast it's moving about. Maybe to give you a better idea of what we're contending with here. Personally, I see myself as more of a web and mobile apps developer, and my specialization revolves around that front. Around 5 years ago, we ran a very informal study on the ideal update velocity for the apps we were maintaining then. We wanted to find out the effort required to keep our apps pretty much on that borderline between updated and bleeding edge. What we found out then was pretty surprising for us at the time. We discovered that on average, a critical dependency in our apps was changing in a significant fashion every 8 days or so. This meant that if we wanted to keep our applications current, somebody will have to sit down roughly every week for every app, look at what's changed, and make a call on whether we incorporate that change and how. I don't know about you, but that sounds insane. We're not even looking at improving. We're just interested in maintaining our applications too. Now, that was 5 years ago, back in 2015. In 2015, AWS released 722 new services and features, which is already a pretty impressive bar if you think about it. Bringing that 5 years forward to 2020, and AWS has now then released 2,757 new services and features. That's almost 4 times what the update velocity was from 5 years ago. And that sort of speed and acceleration is just simply staggering. I'm sure that same study we did 5 years ago will have significantly different results when done today as well. Now, I'm not saying that the AWS pace of innovation is the same across every single field of technology. Everything moves at different clips, but I like to think of this as an indication of just how fast technology itself can change and evolve. When you look at it in this way, it's easy to see how this can be challenging for a lot of companies. This is really one of the more important things we want to focus on when we do prototyping for or even with our customers at AWS. The choice of technologies that our customers use, as well as their command of them, is something we strongly believe is crucial to their success, and we're continuously looking for ways to help out on this front. When we do prototyping, we're particularly interested in helping our customers elevate their thinking about what exactly is possible and to help create long-term value for their businesses in the process. But we also want to help accelerate their innovation processes as well as to help demystify a lot of the uncertainty and concerns about technology in general, especially the newer ones. We always say that we have to be able to run experiments on ideas in as quick and as tight of a turnaround as we practically can. With any problem or challenge, focus on one or two key points about it, form our hypotheses or educated guesses on what we expect to happen, and run a few experiments to either prove or disprove our initial thoughts. By deliberately restricting our problem space to a handful of items, oftentimes the one we feel will have the most impact, we effectively shrink the scope of the work required and allows us to move with greater agility. The point of this exercise is not so much to succeed. In fact, you'll find yourself running into failures time and time again, and you'll need to embrace that. Failure is always an option. I mean, it'll be great if you succeed, of course, but more importantly, when you do fail, this allows you to fail fast and recover just as quickly. This allows you to get your bearings, recalibrate, then try again. Maybe this time with a few new tweaks in place. By building in small, impactful pieces, we gather results much more quickly, and in turn, use those results to drive more intelligent decisions about where to go next. What do we do from here? Is this worthwhile to pursue? And so on. Even our failures will give us valuable insight one way or another, and moving in this way also helps minimize the cost of those failures when they happen. All in all, by increasing the velocity of innovation, we reduce time to market, lower costs, and help you drive market-making services and products. This is the same philosophy we bring into prototyping. We build prototypes for our customers to help demonstrate how an actual system will behave when subjected to similar environments as their current or eventual production systems. Unlike, say, a demo or a proof of concept, which generally try to show that something can simply be done, a prototype is built with an actual business use case or problem in mind. Just like the experiments I was just talking about, the prototypes we build are meant to give a front seat window into seeing exactly how an actual system will function and gather real data points on execution instead of relying on just theory. And again, in following that idea of rapid, quick-fire experiments, we deliberately constrain our prototypes in a number of ways. We make it a point to scope the requirements to just a small handful of business targets, those that we feel have relatively great impact for a small amount of focused effort. Additionally, we generally box in the total effort to around just 3 to 6 weeks. We want to be able to see results as soon as possible. Again, so that we can make more informed decisions as early as possible. All of this gives us early insight on how to position ourselves for an actual production build. Are we using the right technologies? Are we able to scale correctly? How do we react in cases of system failure? That entire iterative process may not make the best sense for some of you, but we've definitely seen it taken to great success time and time again. By working off one or two pieces of a problem and focusing on just those one or two pieces, we're able to invent faster, make decisions faster, react faster. We make mistakes less costly in the long run, and at times, even avoid them entirely. This lends itself to allowing us to innovate and create new things at a much more rapid pace, and eventually fold all that back into better business value. We're not just proving something can be done. Otherwise, we find that we're effectively inventing new things outright. One of my favorite prototyping projects of recent was with this company in ASEAN that manufactured smart electronics for hotels and villas. The problem that they were seeing was that because each of their different clients had different configurations on the field where these electronics were installed, it was costing them substantially to manufacture their products prefabricated for every specific client. They also needed to have specialized people on the ground across different countries just to be able to install and configure these at spec. And this was preventing them from scaling their operations as much as they could be. We worked with them over a few weeks with the governing idea that if we can find a way to allow them to manufacture these electronics as vanilla as possible without any pre-configuration, and finding a way to configure these devices once installed on the field in a secure, automatic, and accessible manner, then we'd be enabling their business to streamline and optimize their production lines. And after a few iterations, we successfully demonstrated how they can use an app on a mobile phone to set up one of their vanilla devices remotely, automatically, and in a secure, controlled fashion. They can now manufacture their products as total blank slates, and they also don't need to maintain highly trained technicians across the world, because now they can just ask their clients to install their mobile app, pair it to their device using Bluetooth, and automatically apply, say, the specific configuration settings for that specific hotel in that specific corner of room 206. And I have to say, we had a lot of fun with that one. So being able to move quickly is great and all, and sure, it does help significantly with the effort to keep with the overwhelming pace of technological evolution. But that in itself is not going to make more sense of the many, many options available to you. There's so much tech to choose from and so little time to touch them all. So how exactly do you decide on what to settle on? I mean, we don't know what we don't know, right? I have to admit that at times it does feel like just throwing some options at the wall and seeing what sticks. But we do learn something new every time we do that, which in turn guides us towards making a better decision of what to throw next, in a manner of speaking. The way we take on prototyping, we make a very concerted effort to seek the aha moments, those critical discoveries, successes, or failures that tell us decisively how to attack a problem. This could be a specific choice of tech or something else entirely. That's not to say that we're all going into this completely blind. We do try to leverage our collective expertise to establish a reasonable starting point and then go from there. With any prototyping engagement, it's always a bit of a treat for myself to get a chance to look at and dissect all the exciting technologies we can potentially use. I really look forward to eventually sharing those with my customers and showing the possibilities of what they can do with it. Let me show you what I mean. I'll walk through some of the key technologies that we particularly keep a close eye on. Some of those you'll already be familiar with, but have some interesting new aspects you might not be aware of. So, virtually any application relies on some form of compute. No matter what you're trying to achieve, the industry, market, geography, most of your critical implementation decisions will hinge on some form of compute, and rightfully so. These are the things that dictate whether or not your users can reach your website, or whether or not your employees can check your emails, or whether or not your monthly sales reports get generated on time. Compute has evolved intensely over the years, and these days, we have compute options in spades. We don't just talk about physical servers now. We have tons of virtualization options, each with different platforms, configurations, architectures, resources. I could just keep going on. We now also have containers and serverless technologies, and I'm pretty sure you've come across them. I love working with them. They enable so many things. For example, containers allow you to scale 100, maybe even 1,000-fold in just a matter of seconds. And serverless technologies effectively reduce a lot of operational overhead and heavy lifting down to mere afterthoughts. You don't have to worry about whether your server is big enough if you don't have a server, right? And both of these allow you to focus your resources more into the activities that let you increase business value, like actually inventing new services and features. There's virtually a compute option for any kind of workload available on AWS. Databases, networking components, web servers, batch processing, high-performance computing. Within an ocean of possible options, prototyping helps distill what exactly needs to be done to best solve a problem, and then match it up to the ideal compute options to most effectively deliver on it. As exciting as all that might sound, I'm afraid it gets better. Some of the more critical business problems we're seeing aren't really concerned about what kind of compute to use. After all, it's simple to switch them up to a different configuration if you change your mind for any reason. Rather, some of the more interesting cases we're seeing are concerned about where to run compute. More and more customers are asking for faster and faster response times, and bringing compute closer to customers does just that. We've done this mostly with edge locations, which brings AWS infrastructure closer to your target markets, and we're continuously looking for more ways to do more with this. We're also looking at ways to offload compute to edge devices and making it much easier to use bespoke electronics with the cloud. But for some workloads, we're seeing we can do even better. Now, there are more options for running applications and systems from the cloud or on-premises, right inside your offices or data centers, and most everywhere in between. Local zones allow us to bring select functionality of an entire AWS region to a location closer to large populations, industries, and IT centers. We're also exploring embedding AWS infrastructure directly into the data centers owned and managed by telco companies, right at the edge of their 5G networks. Both of these drastically reduce the latency of network communications and enable us to build better for the applications that rely on very small response times securely, like self-driving cars, robotic machinery, and smart cities. And if ever you have a need to interface with things in space, it's also possible now to easily deploy infrastructure that communicates with space satellites. Just in case you need the functionality. The sky's the limit with compute. Or maybe not anymore. Right. Anyway, it's no secret that data is becoming increasingly valuable, and Gartner reports that the #1 technology area where CIOs are increasing investment is around business intelligence and data analytics. Having a good operational grasp of data enables so many things for companies both in the short and long terms. And as with anything else, this comes with its own unique set of challenges. Businesses struggle to deal with the sheer amount of available data, as well as the marked increase in the number of different things generating all this data, and the demand for faster and faster turnaround times to actually make sensible use of all this data. Most data operational processes try to achieve a pipeline such as this. We generally want to be able to take and ingest our data points somehow, pass that into processes that clean, project, aggregate, and transform those records, and then somehow translate them into actionable business intelligence. At the heart of it all, data by itself isn't particularly useful. It needs to be molded into the actual information that lead to great decisions and insights. The real problems crop up when we actually try to implement this. The whole idea sounds so simple and straightforward, but the reality of it is more complex. Take, for example, how do we ensure the entire pipeline scales correctly? Considering just how much data we're expecting to take into our systems, how do we make sure we have enough capacity so that we don't miss out on any of those data points? Think about having thousands or millions of users using your services at the same time, every single one generating usage data, log data, transaction records, all of which flow into your systems in parallel. Of course, we also look at it from the other end. We don't want all those resources lying around collecting dust when no one's using them, like, say, during off-peak hours or off-peak season, or when your users are generally sleeping. So the scaling aspect of it has to go both ways. We have to ensure the business scales to accommodate the demand, but also scales just right so that we're not paying for resources we're not using. Prototyping and sitting down to actually build, experiment, and try stuff out helps us see exactly how the data flows will behave. We can, for example, generate synthetic records and simulate projected load against the system and see what happens. If you're planning to build a product that will take in 10,000 records every second, we can simulate exactly that with a prototype and see hard data on results instead of relying on just theory. Again, this leads to better decisions on both the business and technical fronts. And of course, it's not just about the data. It's also about the things that are generating all the data. One thing we like to ask ourselves is this: if you knew the state of everything and could reason on top of that data, what problems can you solve? That's a huge question in and of itself. How do you know the state of everything? Some sources project having 75 billion connected devices online globally by 2025. How do you work off that? And we're not even just talking about electronic devices. In today's world, the number of data sources, as well as the kind of data available at your disposal, is huge. From how fast you can run a kilometer, or how fast you can react to an event in a video game, or how firm you step on your brake pedal when driving. All of these we can build on top of. The thing is, it's also not just about these being data sources. We're now exploring more and more ways to actually push data to these personas, be it an electronic device or an actual user browsing your website. Runners now get timely feedback on any hazards on the trail they're on. People watching a player play a video game can dictate how the game behaves just through text chat. Your vehicle can potentially tell you that you should schedule a servicing soon, since you've been stepping on that brake pedal too hard over the past months. We've spun the ways we're interacting with devices on its head. It's not just about getting data from them. It's now also about directly interacting with and in ways making them do stuff automatically. This bidirectional approach to communication with remote distributed personas and devices enable us to do so many innovative things with a lot of automation. Think about what needs to happen for a food ordering and delivery service to function, and how it's continuously juggling rider location, restaurant timings, customer orders. So many things, right? And in the process of doing just that, taking in data, transforming them into insights, making informed decisions, and making people and things do stuff, it'd be great if we can do as much of that automatically as possible. The less human interaction that needs to happen, the tighter we can make the decision loop, and the quicker we can react to new things. This is where AI and machine learning can really provide an impact. We've grown way beyond AI just being for recognizing handwritten characters or identifying things in a photo, as some people may think. And while we still use AI for those applications, we've grown steadily into making use of machine learning more and more into focused context. I think machine learning is one of the fastest growing technology fields I've seen, with it going from being an aspirational technology to mainstream extremely fast. It's steadily moving from being a nice to have to something integral and core in every business and industry. And while it's long been a tech that's accessible only to major tech companies and academics in the past, it's become more and more accessible over the past few years. We're seeing machine learning drive decisions in all verticals: supply chains, retail, finance, fashion, healthcare, education, you name it. It allows us to recognize trends, behaviors, or otherwise things that are normally invisible to even the most discerning human eyes. If you're interested to hear more about some of the engagements we've done in this field, some of my colleagues will be talking about them in the other sessions in the prototyping track. I'd really recommend you take a look. Their prototypes have been really interesting and I'm confident you'll take away an insight or two as well. The ideal end game is really to enrich that entire data process with machine learning wherever it makes sense. Staying true to that mantra of moving fast, the right application and implementation of machine learning allows your system to move and react even faster. And again, the faster we get observations, the sooner we can make better business decisions. The nice thing about this is that these same machine learning models can also learn from your results in a feedback loop. See data, decide. See result, learn. Rinse and repeat. The more often this happens, the more the entire system benefits. And of course, it's not just about the technology and actually building things. It's also about modernizing processes, teams, functions. Engineers, developers, operations, they're going to want to have visibility of the entire application lifecycle. Everything from writing the code, to deploying, to monitoring performance, and everything in between. All of these quality of life considerations need to be built in somehow in both the engineering processes and the tools they use. But we also have to account for the governance aspect of it. We have to be able to ensure that everything that's happening is within acceptable bounds of security and compliance and applicable audit. If something happens that breaches any of the boundaries we define, then we need to be informed about it as soon as possible. We're doing all these in a number of ways. Part and parcel of the entire prototyping engagement is the sharing of knowledge and assistance in defining and improving all these processes. At the end of each prototyping engagement, there is a very concerted effort to ensure that we hand over to the customer not just what we've built, but also the discoveries, recommendations, and knowledge they'll need to bring the prototype into production. One thing we've consistently been doing is making sure we define our entire infrastructure as code. This allows you to describe exactly how the pieces in the system come together in their exact configurations. This not only makes the entire solution repeatable, but it also doubles as live documentation of what your system should look like at any point in time. One way to do this is using the AWS Cloud Development Kit, or the CDK. This allows you to write up your infrastructure in the same languages that engineers are most likely already familiar with. Like, for example, this spins up an entire Kubernetes cluster on AWS with auto-scaling nodes on a completely new network in around 20 lines of code. This not only makes it simpler to understand what you're working with, but it also can then become subject to the same stringent measures you already subject your source code to. You may already have some form of code review and vetting process for any changes made to applications. Why not do the same for your infrastructure and resources? At the heart of it all, we strive to inject as much intelligent automation as possible across all potential platforms we expect to operate in, whether on the cloud or on the ground. This can mean automation in both technical function or in processes. This, among other things, help us ensure we're enforcing the sufficient governance, security, and compliance to our systems, which I'm sure you'll agree can only benefit whatever we do in the future. If you want to hear more about how we approach prototyping, we run a podcast called Innovation Ambassadors. In each episode, our prototyping engineers and managers share their insight and experiences with working on real customer engagements, the problems they've encountered, the considerations they've made, and the end result and solutions they've come to. I really like episode number 4. So if you don't want to go in from the very start and are looking for a recommendation, well, that'd be mine. It's available most anywhere you listen for podcasts on. I really hope you found this session useful and that I was able to share some viewpoints and insight that can help you and your company in your journey ahead. If you're looking to learn more about AWS, we offer free, on-demand digital training built by AWS experts. We also have classroom-based courses laid by qualified AWS instructors and various certification paths you might want to work towards. All of this is available at the AWS Training and Certification website found at the URL shown on your screen. If you need help on your next big project, don't hesitate to ask your local AWS team to tell you about how the prototyping team can help. We'll be happy to work with you on your next project. Thank you again for attending. We'd appreciate it if you can provide your feedback through the survey after this session. This allows us to better understand the topics and services you'd like most to know more about. I hope to see you around.